Hey, we are in Unit 7, Lesson 8, talking about arcs and sectors. If you remember, an arc is like, the arc is this part, okay? The sector is a piece of a pie, okay? Piece of a pie. An arc is the outside of the circle, a sector is a piece of the pie. The thing I want to review with you before we start in this section is the area of a circle is pi r squared, okay? And the definition of that is all of the space inside the circle, okay? That's the area of the circle. Now, circumference of a circle is 2 pi r, or pi d. R being the radius, d being the diameter. Circumference of a circle is very similar to the perimeter of a polygon. Okay, it's the distance around something, the distance on the outside. So for instance, this would be the circumference of the circle, would be the distance all the way around. Now what we have here is, this one is the distance halfway around the circle. Okay, so using these two equations, let's talk about our warm-up. Evaluate each problem mentally. Yeah, we're just going to calculate it. It's okay. Find the area of the shaded portion, which is a sector of the circle. Now here, this is half of the circle. So the area would be half of the area of the circle. And for here, the radius is 8. So the area of the whole circle is pi 8 squared, which is 64 pi. Okay, the area of the sector is 64 pi divided by 2, or 32 pi. Notice, if I had decided to divide that in half first, like divide the 8 in half first, I get 16 pi, and I already divided it, which is not the same, and therefore incorrect. Okay, we take the area of the circle and then divide it in half. Here I have the circumference. So circumference is, let's not do that in red. Circumference is 2 pi r, where the radius is 8. So 2 pi times 8, which is 16 pi. Now this is just half of the circle, which is our answer. All right? Now with this one, I could actually have divided that 8 divided by 2 first and gotten the same answer. But here, this is linear because nothing is squared. Okay, this one has a squared function. And just like a few lessons, or a few units ago when we talked about dilations and volume and area, when things are squared, they're treated differently. So I need to square everything, then divide by 2. Here, I can divide by 2 anywhere I want. Okay? All right, here, find the area of the shaded portion. So area of the whole circle is going to be pi r squared, 36 pi, but this is just a fourth of a circle. So I'm going to divide that by 4, and I get 9 pi for the area of the sector. Okay, 36 divided by 4 is 9. Now here, the length of the highlighted portion is a fourth of the circumference. So 2 pi r, that's terrible. And it's only a fourth of it. So that's 12 pi over 4, which is 3 pi. Cool. Good review, huh? All right. So now a definition. A sector of a circle is the region enclosed by 2 radii, so the sector. So for A, my sector here, the highlighted portion is this side. We could also talk about this sector, but we're not. Okay? Sector could be the outside or the inside, the outside or the inside. So for each circle, find the area of the shaded sector and the length of the arc that outlines the sector. All units are centimeters. Give your answer in terms of pi. That means we're not going to calculate like times pi. We're going to keep pi there. Let's look at this one. So the area of the shaded sector. I'm going to do the area of the whole. That is pi r squared. So that's 100 pi, but that's for the whole circle. Now, I only want a part of the circle. So how do I do that? Well, I want to set up a ratio. I want to do a portion of the circle. And since a whole circle is 360 degrees, and the portion that's shaded is 270 degrees, that's how I'm going to multiply that. I need my handy dandy calculator. I can probably figure it out without hand, but like I can cancel the zeros and whatever. But I'm going to do 100 pi. Do not calculate the pi, just let that hang out to the end. Times 27 divided by 36. And that gives me 75 pi. All units are centimeters. Okay, makes sense. My head's getting cut off, sorry. All right. All right, let's just do area of sectors first. We'll do arc lengths in a minute. So that was for A. How about B? The area of the whole is pi r squared, which is 144. Yep. That's the area of the whole circle. But I need just the portion that is highlighted. And the whole circle is 360 degrees. My portion highlighted is 60 degrees. So I'm going to do 144 times 60 divided by 360. And I get 24 pi, and the units are centimeters squared. Then that last one, I have to move my head. All right. So the area of the whole is pi r squared. 256 pi. And the portion that's shaded is 135 degrees. The whole circle is 360 degrees. That's just giving you a proportion. So 256 times 135 divided by 360 is 96 pi centimeters squared. Cool? Cool. All right. I'm going to erase all of this now so that we can talk about the arc length. All right, so why don't you push pause and write this down, and we'll continue in a second. All right, let's talk about the circumferences. So remember, we talked about the length of the arc being associated with the circumference. 2 pi r. So let's do it. So we want the circumference of the whole is 2 pi times 10 for A, which is 20 pi. Now, the circumference we're talking about is the one that's associated with the 270 degrees of the circle. So we're still going to multiply that times the ratio. Okay, so 20 pi, we're going to leave pi there, times 270 divided by 360. And I get the circumference there is 15 pi. See, not too bad. So the circumference of the whole thing is going to be 2 pi times 12, which is 24 pi. We multiply it by just the proportion of that piece of pi in the circle. So 24 times 60 divided by 360 is 4 pi. Now it kind of makes sense that that arc length is going to be way smaller than A's arc length. Even though the radius is bigger, the piece of the pie is much, much smaller, so that arc length should be smaller. Okay, now with C, your radius is even bigger. So let's see what happens. So the circumference of the whole thing is 2 pi times 16, which is 32 pi. And then we multiply it by the proportion. So 135 over 360 will give you the piece of the pie. Okay, so the length of that arc is 12. Cool. I hope that made sense. Like I did it the same way every time because, okay, this, I think I have an applet for this too. Hold on. Nope, that applet isn't there. Okay. All right, so it's okay. Task 3. So my says I know how to find the area of a sector for the length of an arc for central angles like 180 degrees or 90 degrees, but I don't know how to do it for central angles that make up more complicated fractions of the circle. In the diagram, the sector's central angle measures theta degrees, and the circle's radius is r units. Use the diagram to tell my how to find the area of a sector and the length of an arc for any angle and radius measure. Well, we do, so if we're doing the area of the sector, we do pi r squared times theta over 360. Okay, and then the length of the arc, so the circumference, the length of the arc, the circumference of the arc, or the length of the arc, whatever, is 2 pi r times theta over 360. Okay, that works for both of them. This image shows a circle with a radius and central angle measurements. Find the area of the shaded sector and the length of the arc defined by the sector. So the area of the sector is going to be pi r squared times 160 over 360. So I got 11.1 pi units squared. And then the length of the arc is going to be 2 pi r times 2 pi r phi times 160 over 360. Times 10 is 4.4 pi. In the area, your units will be squared. The length, your units will be single. Okay? All right. I think that was it. In your packet, you have all of the vocabulary and everything that is really helpful, right? Is there anything else I need to tell you? Let me look. I checked. That's it for today. All right. Great job.